what's going on YouTube? Back with another banger video. In today's video, we gonna be reacting to the design of the Founders Editions of the 5090 series, okay? So NVIDIA just dropped this video. As y'all boys see, I did react to that new launch and stuff. But let's get into it. Am I gonna get a 50 series card? Technically, I could sell my current graphics card to be able to get like a 5070 Ti if I really wanted to, but I'm not gonna do that. I'm gonna just wait until I gotta upgrade, because this PC is still very good. The only thing I need to upgrade in this PC is like my storage, and that's pretty much it, bro. That's pretty much it. Enough yapping. Let's get into the video. RTX 2060.
When you really find the best engineering solution, it often results in a solution that's also
3090 Founders
physically beautiful, and seems like it's there for a reason. This is where craftsmanship really comes to play.
NVIDIA looks at the Founders Edition as our playpen, our place to go push technology forward. Founders Edition is what allows us to sharpen our swords, get out there, be on the front lines with our partners. Ultimately, we believe that by building Founders Edition graphics cards, we can turn that learning in the process back into our GPUs.
We build the Founders Edition because we want to set a new standard and raise the bar for the industry.
The mission of the 50 series graphics card was to figure out how to enable new levels of performance, groundbreaking levels of performance, in smaller form factors than we'd ever delivered them before. So when we started, the task looked like
I'm pretty
mission
sure the
impossible.
50 series cards are supposed to be coming.
The main circuit board by roughly 40
I think,
to 50%,
if not this week,
generation.
next week for
this
sure.
is pretty hard to do when you also are putting even more components on the board, and the chip itself is getting bigger from the previous generation.
I like challenges. I get excited when I hear, this is difficult, this is impossible. Can we make the next generation product smaller, thinner, but more powerful?
The initial thought was that it was impossible. But in reality, the only thing limiting us are the laws of physics.
Okay.
As we look back on previous generations of graphics cards, overall performance of the graphics card has increased substantially. In order to allow for that increase in performance, we need to keep the chip cool.
Otherwise, we end up in a condition where the silicon is trying to run higher performance and faster, but the cooling solution can't keep up, and the GPU has to throttle itself to operate within those conditions.
Now, the thermal solution on our first GPU, Geforce 256, is a simple aluminum extruded heatsink with a single axial fan. Throughout the years and throughout the generations, the thermal solution has changed in order to allow for higher performance, sometimes more successfully than others. In the 20 series, we moved to an axial-based thermal solution. The vapor chamber was the entire length of the card. The chip wanted higher performance, but the thermal solution just wasn't capable. We needed to completely reimagine what a thermal design should look like. When we think about thermal design, it's important to think about how the heat travels from the transistors to the ambient air. Each step it takes along the way, whether it be through the GPU silicon, the thermal interface material, the vapor chamber, can be quantified as what we call a thermal resistance. And it's the job of every thermal engineer to work with the rest of the product team, the mechanical engineers, the electrical engineers, layout, industrial design, to optimize these thermal resistances and minimize them for the best thermal performance.
We realized that the GPU board was a big resistance in the way of cooling the GPU. And so we asked ourselves, how can we effectively get rid of the GPU board?
So that's when we came up with the revolutionary concept behind the 30 series, which was blow-through. By shortening the PCB, we allowed one fan to overhang the heatsink, allowing air to travel directly through the graphics card, greatly reducing acoustics, greatly reducing temperature, and increasing overall thermal performance.
So after a 10-year stagnation of being stuck at 250, 260 watts, we jumped up to 350 watts, one generation.
50.
But something we realized was the graphics card was still getting larger and larger generation to generation.
we did
real.
a prototype. And so we realized if we rotated the GPU PCB on the side, we could actually have 3 fans and blow through a cooler across the entire size of the graphics card. We called it 3/3 blow through. We were pretty excited about it, but we didn't like the idea of taking up 4 slots. It was big, it was unwieldy, it worked in a limited number of chassis. But we took that learnings into the foundation of Blackwell. And we asked ourselves how we could learn from those and do better. We had the novel idea of, hey, what if we could do 2/3 blow through? Now you have to remember, we thought there was no way it was possible to shrink the board by 1/3 to fit 1 fan. And now
Bro,
we
it must
asked the
be so
team to
hard
shrink
to,
the
like,
board
make
by
a graphics
2/3
card,
and
bro.
fit 2
I swear, I
fans.
give people
At the
props for
same
doing
time
it.
as the GPU has actually been growing in size, the power solution has been growing in size. Everything has been growing and going in the opposite
because what's it
direction.
called,
We
bro?
simulated all possible
Like each
permutations
time
of
these like what's it
PCB
called, these
dimensions.
GPUs come out, bro, it consumes like more watts, bro, and you're gonna have to upgrade your power supply.
Product dimension, heat pipe dimension, fan dimension and fan quantity, and the airflow type, the fin thickness and fin shape, and so on.
We wanted to make this Geforce card more powerful with much better thermal design, while also making it lighter and thinner. The first step was sketching numerous of PCB outlines, everything from squares and rectangles to triangles and hourglasses, to position the main PCB at the middle.
In order to enable the dual blow-through cooling
I'm
technology,
not about to lie
bring
though, bro.
cooling to
The
new
most
levels of
exciting thing I'm
performance,
ready for,
we
bro,
had to modularize
is the
the graphics
Reflex
card.
2, bro.
We
Because I
sliced
feel
the
like nowadays,
conventional
bro, these
PCB
games be feeling
into
so
4
delayed,
pieces.
bro.
The main
Like
board
it's
that
like these games feel so delayed, bro. And it's like after a while, the delay is just like insane, bro. You could literally feel the delay and it can affect your performance, bro. And a lot of these games are ping based, bro. So if you got trash ping or not even trash ping, bro, your game could still feel delayed, bro. So I want to see how this Reflex 2 thing is gonna come out, bro. We need the update soon as possible, bro. We need it, bro. This Reflex 2.
carries the GPU,
I'm excited
the
for it.
PCIe daughter board that connects with the main PCB through a connector, the I/O daughter board that carries 3 DP and 1 HDMI connectors, the flexible PCB that connects the main board with the I/O board.
Okay.
One of the huge challenges we had was how are we going to get the DisplayPort 2.1 UHBR20 interfaces from the center to the outside where the user can connect. We realized we had to do something differently.
Historically, when we build our graphics cards, they would all be connected on one PCB. And the specifications in the industry are built around this idea. Introducing any sort of connector or any sort of different interface in the way has traditionally been unheard of in a graphics card.
We worked with vendors and discovered that we could put glass fibers in the substrate of our flex circuit board, and this really enabled and achieved higher performance and better signal integrity. We probably did over 25 different variations of this board, and we found the one that was just right to get the performance that we needed out of it.
From there, the star of the show, the cooling solution, starts with liquid metal tin.
When we think about the thermal interface material, it's incredibly important to have a very high conductivity material between the GPU and the 3D vapor chamber. We've tested hundreds of different thermal interface materials, and we arrived on our highest performance thermal interface material yet, a liquid metal thermal interface material. Time zero performance is very important, but what's really important is making sure it's our most reliable thermal interface material yet. We want to make sure it works not only in all environments, but in all orientations, and allows for the user to use it however they want. What we came up with was a solution that provides an airtight hermetic seal around the GPU die. What this allows for is no oxidization of the material, while also preventing this material from escaping the GPU die region. Traditionally, graphics cards use a vapor chamber and heat pipe combination. Water evaporates above the GPU. It then spreads out through the vapor chamber, condenses, transfers heat through the heat pipes, and evaporates new water, which then spreads to the far edges of the card. In 5090, we want to make everything as dense as possible. And we also want to remove as many thermal resistances as we can, which is why we moved to the first ever 3-dimensional vapor chamber in a discrete graphics card. Now this 3D VC is actually a wing type 3D VC, which means heat pipes are directly connected to the sides of the vapor chamber. This allows the overall thermal solution to be much more dense,
I'm not about
much
to
thinner,
lie, bro. I
and
can't
also
wait to
allows
see
water to travel
performance is gonna
directly
do.
from above the GPU in the evaporator area to the far edges of the card without needing to condense and re-evaporate new water. In the 3D vapor chamber, we've come up with the first ever artery wick. We have high heat flux regions of the GPU that need a lot of water. So we increase the thickness of wick above those areas and pull water into those high heat flux areas while still minimizing the total thickness of wick in the evaporator area.
Those heat pipes travel out into the fin stack of the cooling solution. A traditional fin stack is planar to the PCB. And the RTX 50 series, we have a 3D fin stack.
We scoop out the material below the hub of the fan. This normalizes the pressure drop, but increases the effective fin area below that most effective part of the fan. When we think about an axial fan, the velocity of the air coming off of the fan is not the same
I'm not about to
at
lie,
the
bro. This car
hub
looks
as it is
dope,
at the
though.
outer diameter of the fan blade. Although the angular velocity is the same, the tangential velocity is different and increases with radius. Your blade is traveling at its maximum velocity at the edge of the fan, at the outer
I'm
diameter.
not about to
The
lie,
fans take
chat.
cold air in.
I don't
from
know
your
why I'm saying
chassis,
chat, but
blow
I'm just
through
tired, bro.
the fin stack, and exhaust out over the GPU.
And it's really interesting to think about the overall thermal design as part of the product. No longer is it just a PCB with a heatsink on top. It's a fully integrated thermal, mechanical, electrical solution.
The cooling solution is the entire graphics card, and no detail was left unturned in the process of
But I wonder
developing
what they're
the
gonna do for
RTX
the
50 series
60
graphics
series
cards.
cards.
Something that makes me so proud of our team is the attention to detail that we take on every aspect of the design. It's a work of art.
Every design choice was intentional, balancing power and aesthetic.
We angled the power receptacle, so now users have more space in their case to plug in their power cable. We rotated the DP and HDMI receptacles, so now it's easier to plug in your HDMI and DP connectors. The I/O bracket now has an anti-fingerprint finish. I love working on Geforce because I've been a gamer my whole life. I love working with a team that's so passionate, going through all these challenges together and coming out with something that is the most impressive product that we could possibly build.
The whole company gets involved in this, from the system engineering organizations to the signal integrity organizations to operations. I mean, this is a massive undertaking to develop a graphics card of this complexity. The end result was something beautiful.
As long as we dig into every detail of every challenge, there must be a solution. I look at these challenges as an equation. By turning the knob of each variable, the equation must work.
We get together, we down select, we refine, we focus. We take pieces from one design, another design, feed it into the collective output of the world's best industrial design team in a fabulous product.
Is that it? That's it. Hope you guys liked that video. If you did, like, subscribe, turn on post notifications, and let me know if you're gonna get a Founders Edition 50 series graphics card, bro, when they do release. Me personally, like I said before, since I've had my PC for like, I think almost a year now, pretty much almost a year. April will be official year that I've had my PC for, but I'm not gonna upgrade until this PC starts showing me problems to the point where I gotta upgrade, because I know some people be upgrading like every drop, bro, and I'm not gonna do that personally because my PC still works. But yeah, that's pretty much it. Like, subscribe, turn on post notifications, and I'm out. Peace.